And then the II asks to verify that 30 degree is a root of the equation this cos 2x. And state the other root of this equation for this. So because I do not use the graph paper, I think yes, I think I should just use manual way. But if you use graph paper, so the answer will be in here, in this part. This part, the intersection, this intersection. So this is 30 degree. And then if that is 30 degree, okay, let us say that the x is 30 degrees. So we substitute this, the sine x, the x becomes 30 degree equals to cos 2 times 30 degree. So this sine 30 degree, it is half. So when it is this half, we can know this value is how much. From graph, I think it is 150 degree. So that's for the II. And then for III, it asks us to state the value of this when sine x bigger than cos 2x. So, sorry, smaller than cos 2x. So we have to find when the cos 2x is at the top of this graph of sine x. So the graph that at the top of the sine x, it is here, this and this part only. So the value will be, it is 0 degree. For this part is 0 degree. We have x, yes, equals to this till 30 degree. And then for this part, the second part, it should be 150 degree until 180 degree. Yep, I think that is for the II. So we just use the graph paper and it will be more precise. Okay, that is for number 5. Okay, now we go to number 6. Number 6, we have this picture, and then we have that 1 over 3 pi, and then 6. So this is, of course, also 6. This is also 10. So it asks us to find the angle of this. Okay, I think I will, for this case, we have to draw a line to help us. Okay, this and this, yeah, they are same because they have the same height. So here I will find that one. Let's say this is the height. This is also h. So I will use this 1 over 3 pi. So opposite pi. So sine 1 over 3 pi equals to opposite the h over 6. So h equals to 6 times that is sine 60 degrees. Sine 60 degrees, so it's half square root 3. So it should be 3 square root 3. So now we got already, this is 3 square root 3, the h. And then we can find this theta using this. Also sine theta equals to opposite the h, 3 square root 3 over 10. So we move the sign, becomes sine inverse, so theta equals to sine inverse 3 square root 3 over 10. So that is for the I. And then find the perimeter of the shaded region correct to this. So that's just to find the region. So we we have to find the two sector first. Okay, I will find ADX. A dx. So it should be half theta r squared 1 over 3 pi r squared. So 6 squared. So it will become this 6, 6, and we have 6 pi. And then EBX. Okay, for the angle, just now we already got, oh, sorry. This it has the parameter, so not the sector. So we find first the sector dx. Sorry, we have to find arc of the dx. Arc dx, so it's theta r, so 1 over 3 times the r is 6. So this gone, so it become is pi and 2 pi. And then we have to find the arc of the ex. The ex, so if we calculate this sine inverse 3 square 3 over 10, we shall get this is 0.5464. So that's why the arc will be 10 times this 0.5464. Okay, or we can write down this is 5.464. That's for the arc. And then we have to find the DE. So to find the DE, we have to find this the so we have to find this one first using trigonometry. This one and this one. So for this, we can find it using cosine. So cos 1 over 3 pi, let's say this is x, this is y, equals to x over 6. So 1 over 3 pi, so it's for 60 is half. So x equals to 3. And then after that, we can find the y. So we use also cos. Cos, that one, sine inverse, sine 3 square sine inverse. Cos 0.56. Wait, this I delete first. 5464 equals to the adjacent is y over 10. So we get y equals to cos 0.54 this. Is so it's 10 times cos 0.5464. And then we can get this, the middle one, or DE. So DE equals to, the total of them is 16. So 16 minus 3 minus 10 cos 0.5464. So here we shall get the DE 13 minus 10 cos 0.5464. And then we shall get the total shaded area. It is 2 pi plus 5.464. 64 plus with 13 minus 10 cos 0.5464. And then if I calculate it, I will get 16.2. See, 16.2. Okay, that is for number 6. Now we go to number 7. Number 7, it says that we have a curve dy over dx. The line, this is the normal to the curve. Okay. So here we have the gradient, this. This is y equals to 17 minus x over 3. So we have the gradient, it is minus 1 over 3. So we can change into the normal. So the normal of the curve, because it is say it is normal, so the gradient of the curve at this point, this should be m1 times m2 equals to minus 1. So we have m1 minus 1 over 3 times with m2 equals to minus 1. So m2 equals to 3. So we have the dy over dx is equals to 3, the gradient. So 3 equals to 5 minus 8 over x squared. So I will move the 5 become minus 2 equals to minus 8 over x squared. Then I do cross multiply. Well, minus 8 equals to minus 2x squared. So this is 4 equals to x squared. So x equals to plus minus 2. Let's say the x coordinate is positive, so x equals to 2. And then after this, we can find the y by substituting it to here. So 3y plus 2 equals to 17. So 3y equals to 15, y equals to 5. So we have the coordinate of P is 2, 5. And then it asks us the equation of the curve. Okay, for equation of the curve, we have to use the integration. Integration 5 minus 8x to the power minus 2, I mean into indices dx. So this will become 5x, and then become minus 8x to the power minus 1 over minus 1 plus c. So equals to y. So we can input the x and y value with this 2 and 5 to find the c. So we have 5 equals to 5 times 2. This is plus 8 x to the power minus 1. So it's over 2 plus c. So we have 5 equals to 10 plus 4 plus c. So c equals to minus 9. So the equation of the curve, it is y equals to 5x plus 8x to the power minus 1 minus 9. Okay, that is for number 7. Now we go to number 8.